Hey guys, Mr. Montgomery again. Today we are starting our brand new unit of energy, and today we're really going to be focusing on what energy is, what potential energy is, and kinetic energy. Now you probably heard about these a few years ago back in elementary school and during science class, and so this might just be kind of a refresher because after this lesson we're going to be really diving deep into other forms of energy as well as fossil fuels and more complex topics like that. So, after this lesson, I'm hoping you'll be able to explain the difference between potential and kinetic energy, because we're going to be talking about it quite a bit. So, if, what is energy? If you were to try to explain this concept, if you're a teacher, or if you want to just think to yourself, how would I explain this topic to my little brother, my little sister, or a younger cousin? Someone you know that's just younger that might not be able to understand and comprehend what this word is. Maybe they heard it in a TV show and they asked you, what is energy? What are they talking about? How would you explain it? Maybe you would say something along the lines of energy helps you move. Maybe you're thinking energy let's see, works with electricity, right? Because we talked about electricity before, and we know it's a kind of energy. Or maybe you have something else in mind. I just want you guys to start thinking about how would you even talk about this term? How are you going to explain it? How are you going to make sure someone else can understand what you're saying? Which is a really big deal. Whenever we learn anything, we got to make sure it makes sense when we try to relate it to someone else. So, the basic definition of energy is the ability to do work or to cause change. Now, when I say the ability to do work, I am not talking about getting a job, working at a store, working in an office, none of that. Work in science means something completely different. But what on earth is work? If you had to take a guess, make a prediction, so to say, right? Because in science we're all about predictions and hypotheses. So what would your hypothesis be if you had to pick one of these three? Is it that work is creating energy, transferring energy, or the ability to crush your opponent with your bare hands? Sorry, I got a little excited for that one. So what would you pick? Okay, I'm hoping you picked one of those choices, and the correct answer is transferring energy. That's essentially what work is when we're talking about science. So the funny thing is, I kind of put this one in here as something that we call a red herring, which is a trick. In my classes, a lot of people end up picking creating energy. The fun fact about energy is you can't create it. I know what you're thinking, Mr. Montgomery, you're insane. Of course you can create energy. You can make a battery happen, right? Not quite. Not quite. It turns out energy cannot be created or destroyed, but transferred from one object to another. But I don't want to go too far into that because that's for a different lesson. We'll dive deeper into that when we're talking about energy transformations. So, here is the definition of work. Work is the transfer of energy between objects. Now, normally I would love to play this video for you right here. This is a guy named Eddie Hall who was declared one of the world's strongest men, and that was back in 2016. He is insanely strong, and all these guys that perform in the World's Strongest Man competitions are just as big. These guys weigh 400 plus pounds. They're ginormous. They lift tons of heavy weight. And what Eddie Hall did in this video, you can of course go look it up on YouTube. Just type in Eddie Hall world record deadlift, and it's super cool to watch. He set one of the records for the deadlift back in 2016, where he lifted over 1,000 pounds right off the floor. So you, so just think, you have a little bit over 500 pounds on each side of this barbell. That's insanity. But he did work in this video, right? He took his energy and he transferred it into this barbell with all this weight on it and gave it a ton of what we call potential energy. Now, if you don't recall what potential energy is, don't worry. We're going into that very, very soon. And I will try to remember to bring up Eddie Hall again when we get to it. So, work and energy, they use the same unit of measure. Can't believe I have that typo. Forget the ED there. Just use. They use the same unit of measure, which is joules. And I'm not talking about jewelry, right? Not that kind of jewel. This joule is a little different. And it's spelled different too. Joules. Okay? So that will be the unit of measure if you were to talk about any kind of energy, work, power, all that kind of stuff. You would use the symbol J as the abbreviation after that number. Alright, but let's think back again. And now that we have learned what work is without looking at any notes, which is the correct answer? Is it the transfer of energy between objects? Is it how objects save energy? Or is it how fast energy can be transferred? And I'm really hoping you guys just said, you're crazy, we just did this. It is, of course, the top one, transfer of energy between objects. But the cool thing is, this bottom little definition is a real definition. How fast energy can be transferred? We're actually going to get into that soon too. So, what is a joule? A joule is a unit of measure that can be calculated by multiplying the force and distance together. Right? Super exciting. Okay, maybe it's not that exciting, but that's all it is. It is just when you combine force and distance together, you get energy, and we always use joules to as a unit of measure for energy. And the formula to calculate energy is E for energy equals force times distance. That's it. That's the insane formula. I know it's just mind-boggling how it works, right? Of course not. It's just simple multiplication. So I do have a if you wanted to find out the energy of, let's say we have this woman applying 20 newtons of force onto this nail, and the distance is, let's say, 0.2 meters, you would just multiply those two numbers, and that would give you the amount of energy that is being applied in this scenario. And then after you get that number, you just put the letter J at the end for joules. Okay. Oh, and like I mentioned before, this other definition down here that you guys probably thought was not a real definition, how fast energy can be transferred, that's where we're at now, which is power. Power is the rate at which energy can be transferred. So if the transfer of energy is work, then power is the rate at which energy is transferred, or the amount of energy transferred in a unit of time. Okay, so once you bring time into the equation, you actually have to think about it a little bit different. Alright, so there are two basic forms of energy, and we're going to branch out from these two basic forms in a minute. So the two basic forms are, one, kinetic energy, and then the next one is potential energy. And you can kind of, if you don't recall what these are, that's okay. You can kind of see in the picture what they might be. Okay, in the first picture we see something moving, right? Like this Newton's cradle. And then the other one, you have someone just holding some weight. So, kinetic energy is energy of motion. If there's an object in motion, then it must have kinetic energy. That's it. Very basic, right? I know. Very, very basic. If something moves, it has kinetic energy. Next, we have potential energy. This is stored energy in an object due to its change in position or shape. Like this wind-up car. You change the position of this little white wind-up piece, and you're storing energy inside this little toy car. And then when you finally let go, it then turns that potential energy into kinetic energy, and it moves all around your table, your floor, wherever you're playing with the little car. This kind of energy, you can just think of having the potential to do work. Okay? And there's a few different kinds of potential energy, which is pretty cool. Now, when we think of potential energy, we don't usually think of this wind-up car, even though it absolutely can have potential energy. You can transfer your energy. You can do work, right? You can do work, transfer your energy into the little tiny car, and then it can have potential energy stored up inside of it until you decide to let it go, and then allow it to have kinetic energy. And right there, you just transformed energy twice. That's a little insane. We're transforming energy by winding up a car, and you have a whole chain reaction going on. So, the first different variation of potential energy is probably the one we're most familiar with, and that's gravitational potential energy. This is when an object gets more potential energy the higher it is. So if you were to climb on top of a slide, you're giving yourself potential energy because you're higher up. And when you get to the slide, you can glide right down, right? And then you have kinetic energy. The same thing happens with any object you bring up with you. You can bring up a bowling ball up to the slide, right? And instead, roll the bowling ball down the slide, and then you're transferring that potential energy into kinetic energy. And if the slide was higher, the bowling ball would then have even more kinetic or potential energy that you could transform into kinetic energy once you release it. And finally, the last type of potential energy is elastic potential energy. This is when an object gains a form of potential energy from either being stretched or compressed. So in the picture, you see a spring, right? We see pushing a spring together, and then another picture, you're pulling it apart. Either way, there is resistance happening in both pictures. You could even think about if you've ever written with a pen. Of course, you've written with a pen. We all have. We're not crazy. We know what a pen is. But did you realize that there is a spring in a pen? A really small, skinny spring that helps hold your ink into place. Now, when you screw on the top of that pen, you're compressing that spring just like in the picture right here. And you're storing energy. You now are constantly carrying around potential energy every single place you go with this pen. And then, if you unscrew the top, what normally happens? You have the ink tube shoot out of the pen, and sometimes we lose that, and sometimes we lose the spring. Or if you were to take that same spring and slightly pull it apart, and then let it go, it'll snap back into place. So that is just one very, very easy example of elastic potential energy. You could also think of like a bow and arrow. A bow and arrow, you have to pull that string back, and it bends the bow. You're stretching the material as much as you can in order to give it more potential energy. So that way when you release it, the arrow flies through the air, and you will hit your target. Okay, and this will be our last lesson check for the day, or for the lesson really. What are the two basic types of energy that we learned about? Now keep in mind the word basic, that is crucial. Is it elastic and kinetic? Is it kinetic and gravitational? Is it potential energy and gravitational potential energy? Or is it kinetic energy and potential energy? Okay, I'm hoping you picked an answer. And the correct choice is kinetic and potential. Those are the two most basic forms of energy that we have access to. So if we're starting to talk about elastic potential energy, that's branching off of potential energy itself. So we can't say that this is one of the most basic types. Same thing with gravitational potential energy. Gravitational potential energy is branching off of just what potential energy is in the first place. So we can't say that this is one of the most basic forms either. So that's why we are left with just kinetic and basic potential energy. Okay? So I'm hoping that this lesson helped you guys out a little bit. Maybe it helped you review. Maybe it helped you understand different variations of kinetic and potential energy. But if you have any questions, make sure you ask your teacher if you're not in my class. If you are in my class, just ask me and I'll help you guys out. All right? So have a great day, and I will see you guys during the next lesson.